Picture the North Atlantic in the dead of winter, 1983. The water is a churning, freezing black abyss, and the wind across the flight deck of the USS Nimitz is biting through flight suits at 30 knots. Somewhere 200 miles out in the pitch-black sky, a Soviet Tupolev Tu 22M backfire bomber is dropping its nose, accelerating to Mach 1.5, and preparing to ripple fire a volley of supersonic cruise missiles aimed directly at the American carrier strike group. In any previous era of naval warfare, the carrier would be moments away from a fiery, catastrophic death. But in this era, standing between that Soviet bomber and the 5,000 sailors on the Nimitz is a 20-ton piece of Grumman titanium, armed with a radar system that can see over the horizon and missiles that cost $1 million apiece. This is the Grumman F-14 Tomcat. It is arguably the most famous fighter jet in American history, immortalized by Hollywood and worshipped by aviation enthusiasts. But behind the slick movies, the aviator sunglasses, and the roaring afterburners lies a cold, brutal, and highly mathematical reality of Cold War strategic doctrine. The Tomcat was not built to dogfight MiGs over a desert, even though it could. It was built for one specific, apocalyptic purpose, which was to act as the ultimate shield for the United States Navy against a saturated Soviet bomber attack. Before we dive deep into the titanium bones and the pulse Doppler brain of this legendary machine, let me ask you a question. Was the F-14 Tomcat truly the greatest fleet defender ever built? Or was it an over-engineered, maintenance-heavy diva that just happened to have the best public relations campaign in military history? Drop your thoughts in the comments below. And if you want to understand the raw, unfiltered truth of military engineering and tactical history, make sure you hit that subscribe button and ring the bell so you never miss an analysis. To understand why the F-14 Tomcat exists, we have to completely strip away the Hollywood glamour and look at the terrifying strategic nightmare the US Navy faced in the decades following the Second World War. The roots of the Tomcat do not begin in the 1970s. They begin in April 1945, in the blood-soaked waters off the coast of Okinawa. During the Okinawa campaign, the US Navy encountered a threat that fundamentally changed naval warfare forever, which was the Japanese kamikaze. The Navy positioned radar picket destroyers miles away from the main carrier force to provide early warning and absorb the initial blows. These destroyers took horrific casualties, but they taught American naval strategists a permanent, unbreakable lesson. Distance is survival. If you let a dedicated, fast-moving threat get within visual range of a fleet carrier, you have already lost the battle. You must kill the threat as far away from the flight deck as physically possible. Fast forward to the late 1950s and early 1960s, and the kamikaze aircraft had been replaced by something infinitely more dangerous. The Soviet Union, lacking a massive surface fleet to challenge the US Navy head-on, developed an asymmetric doctrine focused on long-range naval aviation and massive anti-ship cruise missiles. The Soviets built fleets of heavy bombers like the Tu-16 Badger and later the terrifying Tu-22M. backfire. These were not strategic bombers meant to drop nuclear gravity bombs on cities. They were maritime strike platforms, designed to fly out over the open ocean and launch weapons like the Kh-22 cruise missile. The Kh-22, known to NATO as the AS-4 Kitchen, was a monster. It was 40 feet long, weighed 13,000 pounds, and flew at Mach 4.6, carrying either a 2,000-pound conventional-shaped charge or a nuclear. The Soviet doctrine was simple and brutal. They would coordinate regiment-sized raids, launching 20 to 30 bombers from different vectors to converge on an American carrier strike group simultaneously. They would ripple-fire dozens of these massive missiles from 200 miles away. The goal was saturation. Even if the American surface-to-air missiles shot down 95% of the incoming weapons, the one or two that slipped through would instantly vaporize a nuclear-powered aircraft carrier. Faced with this existential threat, the U.S. Navy realized that point defense systems on ships were not enough. They needed to push their defensive perimeter out to 200, 300, or even 400 miles. This birthed the doctrine of the outer air battle. The concept was to maintain a combat air patrol of heavy interceptors, loitering hundreds of miles from the carrier, coordinated by airborne early warning radar planes. The mandate was clear. Do not try to shoot the arrows, because there are too many of them, and they are too fast. You must shoot the archer before he releases the bowstring. You must kill the Soviet bomber before it reaches its launch point. To execute the outer air battle, the Navy needed an interceptor with massive range, incredible loiter time, a radar powerful enough to see bombers at extreme distances, and missiles fast enough to kill them. Initially, the political establishment in Washington thought they had the perfect solution. And this brings us to one of the most controversial procurement disasters in American military history. Secretary of Defense Robert McNamara, a man obsessed with corporate efficiency and cost-cutting, decreed that the Air Force and the Navy would share a single fighter platform. This was the Tactical Fighter Experimental Program, or TFX, which became the General Dynamics F-101-11. The Air Force wanted a low-level supersonic strike bomber, while the Navy wanted a high-altitude fleet defense interceptor. Forcing these two completely contradictory missions into one airframe was an engineering paradox. The Navy variant, the F-11B, was a disaster. To accommodate the heavy AWG-9 radar and 6 massive Phoenix missiles, the aircraft became bloated. It weighed an astonishing 85,000 pounds fully loaded. Bringing an 85,000-pound aircraft down onto a pitching carrier deck at night is not a tactical maneuver. It is an invitation to a funeral. The F-111B was underpowered, sluggish, and had terrible visibility for carrier landings. In a legendary congressional hearing in 1968, Vice Admiral Thomas Connolly was asked if more powerful engines would fix the F-111B. His response delivered the killing blow to the program. He stated, on the record, that there is not enough thrust in all of Christendom to fix this airplane. With the F-111B dead, The Navy was left dangerously exposed, and the clock was ticking as Soviet bomber technology advanced. They urgently launched the VFX program, seeking a dedicated, purpose-built fleet defender. Enter the Grumman Aircraft Engineering Corporation. Grumman was known in the aviation world as the Iron Works. They had built the backbone of naval aviation during World War II, producing legendary fighters like the F-4F Wildcat and the F-6F Hellcat. Grumman understood something that the Air Force and political bureaucrats did not. They understood the violent, unforgiving environment of the aircraft carrier. They knew that a carrier aircraft had to be built like a bridge, capable of withstanding the bone-crushing forces of catapult launches and arrested recoveries. Grumman took the engines, the AWG-9 radar, and the AIM-54 Phoenix missiles from the failed F-11B project and wrapped an entirely new aerodynamically brilliant airframe around them. This was Design 303, which would become the F-14 Tomcat. When we compare the opposing forces of this era, the contrast in military doctrine and industrial philosophy is staggering. On the Soviet side, you had a doctrine of brute force and centralized control. The Soviet naval aviation, or AVMF, relied on mass production of heavy bombers and the sheer kinetic energy of their anti-ship missiles. They did not prioritize individual pilot initiative. Their bomber crews were highly trained technicians executing a rigid, pre-planned strike profile directed by ground controllers and satellite targeting data. The Soviet industrial base excelled at producing massive rocket motors and crude but effective radar seekers. On the American side, the doctrine relied on decentralized execution, technological superiority, and the highly specialized training of the naval aviator. The U.S. industrial base was pushing the absolute bleeding edge of microelectronics, materials science, and aerodynamic design. The Tomcat was the ultimate manifestation of this American philosophy. To fulfill the contradictory requirements of loitering on station for hours at low speeds, and then accelerating to Mach 2.3 to intercept a bomber, Grumman utilized variable sweep wings. This was not a new concept, but the way Grumman implemented it was revolutionary. Unlike earlier variable geometry aircraft, where the pilot had to manually adjust the wing sweep, the F-14 featured a central air data computer. This mechanical and electronic marvel automatically adjusted the wing sweep based on the aircraft's Mach number and altitude, constantly optimizing the lift-to-drag ratio without the pilot ever having to touch a lever. When the wings were fully forward at 20 degrees, the F-14 had a massive wingspan that provided incredible lift, allowing this heavy fighter to land on a carrier deck at a relatively slow 125 knots. When the wings swept back 20 degrees, the Tomcat turned into a supersonic dart, minimizing drag for high-speed intercepts. But building a variable sweep wing fighter that can survive carrier operations requires overcoming a massive engineering hurdle. The pivot point where the wings attach to the fuselage has to absorb astronomical stress. To solve this, Grumman engineered a massive wing center section box made almost entirely of titanium. Titanium is incredibly strong and lightweight, But in the late 1960s, it was notoriously difficult to work with. It was brittle, hard to machine, and required vacuum chamber electron beam welding to join the pieces together. Grumman had to pioneer entirely new manufacturing techniques just to build the skeleton of the Tomcat. There is a profound historical irony. Here, as much of the titanium used to build the aircraft designed to destroy Soviet bombers was secretly sourced from the Soviet Union itself through a network of shell companies established by the CIA. This level of engineering ambition draws a direct historical parallel to the development of the Lockheed P-38 Lightning during World War II. Just like the Tomcat, the P-38 was designed as a heavy, twin-engine interceptor meant to climb fast, fly long distances, and carry a concentrated package of heavy firepower to destroy enemy bombers before they could reach the fleet or the base. Both aircraft broke the conventional rules of fighter design for their respective eras, prioritizing speed, range, and lethality over lightweight maneuverability. But the P-38 operated from long, stable runways on solid ground. The F-14 had to do all of this while operating from a pitching flight deck in the middle of the ocean in zero visibility, relying heavily on the human element. And that human element was divided into two distinct roles inside the cockpit. In the front seat was the pilot, responsible for flying the aircraft, managing the energy, and handling close-in dogfights. But in the back seat sat the radar interceptor officer, or RIO. The RIO was not a co-pilot. The RIO was the tactical commander of the airspace, the brain operating the most powerful radar ever put into a fighter aircraft at that time. This was the Hughes AWG-9 pulse Doppler radar system. The AWG-9 was an absolute monster, a mechanical scanned array radar that could output 10 kilowatts of power. It had a detection range of over 115 statute miles for bomber-sized targets. But raw range was not its most impressive feature. The true magic of the AWG-9 was its track-while-scan mode. Using complex early microprocessors, the radar could maintain a continuous search of the airspace while simultaneously tracking up to 24 individual targets. And from those 24 targets, the AWG-9 could prioritize the 6 most dangerous threats and guide 6 separate AIM-54 Phoenix missiles to intercept them simultaneously. How do you stop a swarm of supersonic cruise missiles fired from bombers that you cannot even see yet? You build a radar that can see over the curvature of the Earth, and you pair it with a missile that flies faster than a rifle bullet. The AIM-54 Phoenix was the teeth of the Tomcat. Weighing in at over 1,000 pounds and measuring 13 feet long, the Phoenix was more like a flying telephone pole than a traditional air-to-air missile. When launched, the Phoenix would ignite its massive solid rocket motor and climb into the stratosphere, reaching altitudes of over 80,000 feet. Up there in the thin air, it would accelerate to speeds exceeding Mach 5. It would cruise toward the target area using semi-active radar homing, receiving course updates from the Tomcat's AWG-9 radar. Then, at about 11 miles from the target, the Phoenix would go pitbull. It would turn on its own internal active radar seeker, lock onto the Soviet bomber, and dive down from the stratosphere at hypersonic speeds, carrying a 135-pound continuous rod fragmentation warhead. The kinetic energy alone of a 1,000-pound missile hitting an aircraft at Mach 5 is enough to tear a bomber in half, even before the warhead detonates. This combination of the F-14 airframe, the AWG-9 radar, and the AIM-54 Phoenix missile created an impenetrable bubble around the carrier strike group. But having the ultimate weapon on paper is one thing. Taking a highly complex, titanium-boned variable geometry fighter with temperamental engines and putting it into the hands of 25-year-old aviators in the middle of the ocean is a completely different reality. The transition from the sterile environment of Grumman's engineering labs to the brutal, salt spray reality of fleet deployment would test the Tomcat and the men who flew it to their absolute limits. The reality of operating this massive interceptor began the moment the rubber tires of the Tomcat hit the non-skid surface of the flight deck. For all its aerodynamic brilliance and radar supremacy, the early F-14 Tomcat harbored a dark, lethal secret buried deep inside its titanium fuselage. This was the Pratt & Whitney TF-30 turbofan engine. The TF-30 was originally designed for the 11 bomber, an aircraft meant to fly straight and level at high speeds and low altitudes. It was never meant to be thrown into violent, high-G dogfighting maneuvers. When a fighter jet pulls a high angle of attack, pointing its nose up while the aircraft's momentum continues forward, the airflow entering the engine intakes becomes highly turbulent and distorted. Fighter engines must be robust enough to swallow this turbulent air without choking. The TF-30 was not. If an F-14 pilot got too aggressive with the throttle during a hard turn, the disrupted airflow would cause a catastrophic failure known as a compressor stall. The engine would violently backfire, shooting flames out of the front intake and instantly losing all thrust. Because the Tomcat's engines were spaced 9 feet apart to create a wide lifting body, losing one engine at low speed and high angle of attack created a massive, violent yawing motion. The asymmetrical thrust from the remaining good engine would snap the nose of the aircraft to the side, throwing the 20-ton fighter into a vicious, unrecoverable flat spin. The aircraft would fall out of the sky like a falling leaf, spinning violently while pinning the crew to their seats with extreme G-forces, making it nearly impossible to reach the ejection handles. This engine flaw draws a stark historical parallel to the Boeing B-29 Superfortress of the Second World War. The B-29 was a technological marvel, featuring pressurized cabins and remote-controlled gun turrets, but it was cursed with the Wright R-3T300-5D radial engines. Those engines were notorious for overheating and catching fire, to the point where American bomber crews taking off from the Marianas feared their own engines just as much as they feared Japanese anti-aircraft fire. Similarly, early Tomcat crews found themselves fighting their own airplane just as much as they fought the enemy. Why would the United States Navy accept a premier fighter jet with such a fatal, well-documented flaw? The brutal answer is a combination of desperation, budget cuts, and the ticking clock of the Cold War. The Navy needed the F-14 on the decks immediately to counter the Soviet bomber threat, and they simply did not have the time or the funding to wait for a new, purpose-built fighter engine to be developed. They accepted the risk, relying on the superior training and discipline and of naval aviators to fly around the engine's limitations. Pilots had to treat the throttles with extreme delicacy, constantly monitoring their yaw and angle of attack, turning dogfights into a high-stakes mathematical balancing act. And despite being designed to kill bombers from 100 miles away, the Navy knew that sooner or later the Tomcat would be forced into a close-range knife fight. To survive within visual range, the F-14 was equipped with a lethal close-in arsenal. Buried in the left side of the forward fuselage was the M61A1 Vulcan, a 20mm, 6-barrel rotary cannon capable of firing 6,000 rounds per minute. On the wing gloves, it carried the AIM-9 Sidewinder, a heat-seeking missile for short-range engagements, and the AIM-7 Sparrow, a medium-range, semi-active radar homing missile. But carrying this massive arsenal and the heavy AWG-9 radar came with an agonizing logistical cost. The F-14 was an absolute maintenance nightmare. For every single hour the Tomcat spent in the air, it required between 40 and 50 hours of agonizing, back-breaking maintenance on the deck. The variable sweep wing mechanism, while brilliant in the air, was a complex labyrinth of gears, actuators, and hydraulics. The aircraft utilized a hydraulic system pressurized to 3,000 pounds per square inch, running through miles of titanium tubing. The violent, bone-jarring impact of a carrier landing, where the aircraft slams into the deck at 130 miles per hour and goes to zero in 2 seconds, would routinely fracture these lines. Hydraulic fluid would leak continuously, and aviation structural mechanics spent their deployments covered in grease, working in the freezing wind or the blistering heat, just to keep the jets flyable. This logistical burden is highly reminiscent of the German Tiger tank during the Second World War. The Tiger possessed unmatched firepower and nearly impenetrable armor, but it was over-engineered, mechanically fragile, and consumed massive amounts of resources. The Tiger spent more time broken down in repair depots than it did dominating the battlefield. The Tomcat was the airborne equivalent, a thoroughbred racehorse that required a small army of technicians just to make it to the starting gate. Can a weapon system truly be considered effective if it spends half of its operational life in the hangar bay being repaired? In the calculus of Cold War deterrence, the answer was yes, because the mere presence of the F-14 on a carrier deck completely altered the strategic geometry of the Soviet Union. But the ultimate test of the Tomcat would not come against a swarm of Soviet bombers was over the North Atlantic. It would come in the blistering heat of the Mediterranean Sea against a completely different enemy, proving that Grumman's interceptor was a terrifyingly capable dogfighter. In the summer of 1981, the United States Navy launched a massive freedom of navigation exercise in the Gulf of Sidra, off the coast of Libya. Libyan dictator Muammar Gaddafi had illegally claimed the entire Gulf as territorial waters, drawing what he called the line of death. The newly elected American President, Ronald Reagan, ordered the USS Nimitz and the USS Forrestal to cross that line and dare the Libyans to do something about it. The air wing of the Nimitz included Fighter Squadron 41, the Black Aces, flying the F-14A Tomcat. On the morning of August 19, 1981, the tension in the Combat Information Center of the Nimitz was palpable. At approximately 07 hours, an E-2C Hawkeye airborne early warning aircraft picked up two fast-moving radar contacts launching from a Libyan airbase near Tripoli. The Hawkeye controllers vectored two F-14s toward the bogies. The lead Tomcat, call sign Fast Eagle 102, was piloted by Commander Henry Hank Kleeman with Lieutenant Dave D.J. Venlet in the I.O. seat. The wingman, Fast Eagle 107, was piloted by Lieutenant Lawrence Music Muchinski, with Lieutenant Junior Grade James Amos Anderson operating the radar. The Tomcats pushed their throttles forward, their variable sweep wings automatically sliding back to reduce drag as they accelerated to intercept. Venlet and Anderson locked up the targets using the AWG-9 radar, feeding continuous range and bearing data to their pilots. At 8 miles out, Commander Kleeman gained a visual tally on the contacts. They were two Soviet-built Sukhoi Su-22 fitters, single-engine, variable sweep-wing fighter bombers. The rules of engagement were strict, dictating that the Americans could not fire unless they were fired upon. Kleeman and Muchinski initiated a tactical split, separating their aircraft to force the Libyans to choose a single target, a classic defensive maneuver. The Libyan flight leader made a fatal tactical error. Instead of turning away, the lead Su-22 aggressively pulled its nose up and fired a Vimpel K-30 to NATO as the AA-2 Atoll, directly at Kleeman's Tomcat. The Atoll was a crude early-generation heat-seeking missile, effectively a reverse-engineered copy of an early American Sidewinder. Firing a heat-seeker head-on at an aircraft moving at a closure rate of over 1,000 miles per hour is practically useless, as the missile's seeker head cannot track the heat of the exhaust from the front. The missile failed to track, dropping harmlessly into the Mediterranean. But the Libyan had just committed an act of war, and the rules of engagement instantly changed to weapons-free. What followed was a brutal, textbook demonstration of energy management and aerodynamic superiority. Kleeman violently pulled his Tomcat into a hard climbing turn. As his airspeed bled off, the Central Air Data Computer automatically commanded the wings to sweep forward to 20 degrees. The massive lifting surface of the Tomcat bit into the air, allowing the heavy interceptor to outturn the lighter Libyan fighter with astonishing agility. Kleeman rolled in behind the lead Su-22, achieving a perfect rear aspect firing position. He selected an AIM-9L Sidewinder, a highly advanced, all-aspect heat-seeking missile. The tone in his headset transitioned from a low growl to a high-pitched shriek, indicating a solid infrared lock on the fitter's engine exhaust. Kleeman squeezed the trigger on his control stick, calling Fox 2. The Sidewinder leapt off the rail, leaving a trail of white smoke as it covered the short distance in a matter of seconds. The missile detonated directly inside the tailpipe of the Su-22, instantly obliterating the rear half of the aircraft and sending it spiraling into the sea. Meanwhile, Lieutenant Muczynski in Fast Eagle 107 had tracked the second Libyan fitter. The Libyan wingman, seeing his leader turned into a fireball, panicked and threw his aircraft into a hard right turn, attempting to flee back toward the coast. Muczynski pulled high G, dragging his Tomcat across the turn circle to cut off the Libyan's escape route. He achieved a lock, fired his own AIM-9L Sidewinder, and watched as the missile struck the second fitter right at the wing root. The Su-22 disintegrated in a massive explosion. The entire engagement, from the moment the Libyan fired his missile to the destruction of the second fitter, lasted less than 1 minute. This brief, violent clash proved that despite its massive size and interceptor pedigree, the Tomcat was a lethal knife fighter in the hands of superbly trained naval aviators. The Libyan pilots relied on rigid ground control and lacked the situational awareness and fluid tactical thinking of the Americans. This engagement mirrors the Pacific theater of World War II, where American pilots flying the heavier, less maneuverable F-4F Wildcat consistently defeated the nimble Japanese Zero. The Americans did not try to outturn the Zero in a flat circle, but instead used superior tactics, energy management, and mutual support, like the famous Thack Weave, to dominate the airspace. The Tomcat crews used their technology and their training to completely outclass an enemy flying inferior hardware. 8 years later, the Tomcat would once again draw blood in the exact same waters. On January 4, 1989, during the second Gulf of Sidra incident, 2 F-14s from Fighter Squadron 32, the Swordsmen, operating off the USS John F. Kennedy, were intercepted by 2 Libyan MiG-23 floggers. The MiG-23 was a significantly more dangerous threat than the Su-22, possessing better speed, a more capable radar, and longer-range missiles. This engagement was a masterclass in beyond-visual-range radar tactics, transitioning into a close-quarters dogfight. The American Rios locked the MiGs at extreme range, but the Libyans continued to maneuver aggressively, attempting to achieve a firing solution. After multiple warnings and evasive maneuvers by the Tomcats, the hostile intent of the MiGs was undeniable. The lead Tomcat fired an AIM-7 Sparrow radar-guided missile, but it failed to track. The wingman followed up with a second Sparrow, scoring a direct hit on the trailing MiG. The lead Tomcat then closed the distance, merging with the remaining MiG-23 and destroying it with a short-range AIM-9 Sidewinder. Once again, the Grumman Ironworks had proven its dominance. The F-14 had successfully defended the fleet, not from Soviet bombers, but from regional aggressors, cementing its status as the undisputed king of the Mediterranean airspace. But as the 1980s drew to a close, the geopolitical tectonic plates of the world were shifting violently. The Berlin Wall fell, the Soviet Union collapsed, and the massive fleets of Tu-22M backfire bombers that the Tomcat was built to destroy suddenly began rusting away on neglected runways in Russia and Ukraine. The existential threat that justified the Tomcat's massive maintenance budget and specialized design vanished almost overnight. As the 1990s dawned, the United States Navy looked at its carrier decks and realized they were operating a fleet of incredibly expensive, maintenance-heavy interceptors designed for a war that was never going to happen. The F-14 was a dinosaur staring at an incoming asteroid, and military budget committees in Washington were already sharpening their knives to cut the program entirely. If the Tomcat was going to survive in the post-Cold War era, it could no longer just be a fleet defender looking up at the sky. It would have to learn how to look down at the dirt, and it would have to undergo a technological transformation so radical that it would change the very nature of naval aviation. To transform a dedicated fleet defender into a precision strike bomber, the Navy had to bypass its own bureaucratic red tape. The low-altitude navigation and targeting infrared for night system, known as the LANTRN pod, was originally an Air Force targeting system. The Navy did not have the time or the billion-dollar budget to fully integrate this pod into the Tomcat's ancient mission computers and avionics architecture. So, Grumman engineers did something incredibly pragmatic and slightly rebellious. They effectively hardwired the targeting pod directly into the displays of the radar intercept officer in the back seat. They installed a specialized hand controller, fundamentally turning the radar operator into a bombardier. The Tomcat could now self-lace targets on the ground and drop GBU-12 and GBU-16 laser-guided bombs with pinpoint accuracy. This birthed the era of the Bombcat. How do you convince a fighter pilot who spent his entire career training to shoot down MiGs at Mach 2 to suddenly care about dropping a piece of iron on a concrete bridge in the Balkans? You give him a laser-guided bomb and tell him he is the only one with the fuel capacity to reach the target and make it back to the boat. The FCA-18 Hornet, which was the Navy's new darling multi-role fighter, was a fantastic machine. But it had a fatal strategic flaw. It lacked legs. The Hornet had a notoriously short combat radius, forcing it to carry multiple external fuel tanks just to reach a target, which severely limited its bomb load and required constant support from vulnerable aerial refueling tankers. The F-14, by contrast, was a massive flying gas station. It could carry a heavy load of laser-guided munitions, fly deep into hostile territory over Bosnia or Kosovo, loiter on station for hours waiting for ground forces to call in a strike, and still have enough fuel to return to the carrier. This radical shift in mission profile draws a direct historical parallel to the Boeing B-52 Stratofortress during the Vietnam War. The B-52 was originally designed as a high-altitude nuclear bomber meant to vaporize Soviet cities from the stratosphere. But when the geopolitical reality shifted, the Air Force modified the massive bomber to carry dozens of conventional iron bombs, turning it into a tactical close air support weapon, raining destruction on jungle supply trails during Operation Arclight. The Tomcat underwent the exact same philosophical evolution, transitioning from a high-altitude nuclear bomber killer to a low-altitude precision tactical strike platform. But dropping bombs required flying at lower altitudes, where the air is thicker and the aerodynamic stresses are brutal. The original TF-30 engines, which were a lethal liability in a dogfight, were finally replaced in the F-14B and F-14D models. The Navy selected the General Electric F-110 afterburning turbofan. This engine was an absolute revelation for the airframe. It provided nearly 30,000 pounds of thrust per engine, completely eliminating the terrifying compressor stall issue that had killed so many aviators. A Tomcat equipped with F-110 engines could launch from an aircraft carrier catapult without even using its afterburners, a feat of raw mechanical power that left Hornet pilots staring in envy. However, raw power does not win budget hearings in Washington. By the early 1990s, the Secretary of Defense, Dick Cheney, looked at the F-14 program and saw a fiscal black hole. The F-14D Super Tomcat, which featured upgraded digital avionics and a new APG-71 radar, was an incredibly capable machine, but it was astronomically expensive to produce. Grumman's manufacturing lines in Long Island were costly to keep open, and the political momentum shifted entirely toward McDonnell Douglas and their proposal for the FCA-18E and F Super Hornet. Does the military exist to field the absolute most lethal and dominant weapon system possible? Or does it exist to field a fleet that is merely good enough, but can actually be maintained within a peacetime budget? The answer was the spreadsheet. The Tomcat was bleeding the Navy's maintenance budget dry. As the airframes aged, the massive titanium wing boxes began to show microscopic stress fractures from decades of violent carrier landings. The complex hydraulic systems, operating at 3,000 pounds of pressure, leaked constantly, turning hangar bays into hazardous slip zones. It was not uncommon for a single F-14 to require over 50 hours of grueling knuckle-bodygut maintenance for every 1 hour it spent in the air. Maintainers were forced to cannibalize parts from one jet just to keep another one flying, creating a fleet of hangar queens. The Super Hornet, while slower and possessing less range, was a modern, reliable, and easily maintainable aircraft. It was the safe, economical choice for a navy that no longer had to fight the Soviet Union. This painful transition perfectly mirrors the final retirement of the Iowa-class battleships after the Gulf War in 1991. Ships like the USS Missouri and USS Wisconsin possessed unmatched naval gunfire support capabilities, able to hurl 2,000-pound high-explosive projectiles 20 miles inland to shatter enemy bunkers. But they required a crew of nearly 2,000 sailors and consumed a massive portion of the surface fleet's operating budget. Just as the Navy traded the brute force of the battleship for the efficiency of the guided missile destroyer, they traded the extreme performance of the Tomcat for the multi-role efficiency of the Super Hornet. But there was another bizarre, deeply geopolitical reason. The United States government wanted the F-14 completely eradicated from existence. In the 1970s, before the Islamic Revolution, the United States sold 79 F-14 Tomcats to the Shah of Iran to counter Soviet MiG-25 reconnaissance flights. When the Shah was overthrown in 1979, those state-of-the-art interceptors fell directly into the hands of the Ayatollah Khomeini. During the brutal Iran-Iraq War in the 1980s, the Iranian Air Force used their Tomcats to devastating effect, shooting down dozens of Iraqi MiGs and Mirages. The United States found itself a faff in a terrifying intelligence nightmare. A hostile foreign power was operating America's premier fleet defender, and they were desperate for spare parts to keep them flying. Iranian intelligence agents set up elaborate black market shell companies across the globe, attempting to smuggle AWG-9 radar components, Phoenix missile batteries, and titanium structural parts out of the United States. The Department of Defense and federal law enforcement spent decades playing a high-stakes game of whack-a-mole, hunting down these smuggling rings. The only way to permanently blind the Iranian Tomcat fleet was to completely destroy the global supply chain. When the United States Navy finally retired the F-14, they did not just send them to the boneyard in the Arizona desert to sit in the sun like other retired fighters. They subjected them to a brutal, systematic execution. The aircraft were stripped of their classified avionics, and then their massive titanium fuselages were literally torn to pieces by heavy industrial shredders. The Navy reduced its most legendary fighter jet to piles of unrecognizable scrap metal, just to ensure that not a single bolt or hydraulic actuator could ever be smuggled into Tehran. But before the shredders claimed them, the Tomcat had one final war to fight. Following the terror attacks of September 11, 2001, the United States military unleashed Operation Enduring Freedom in Afghanistan. The geography of this conflict presented a massive logistical hurdle for naval aviation. Afghanistan is a landlocked country, meaning Navy carriers had to operate from the North Arabian Sea. Strike aircraft had to fly hundreds of miles north, passing through Pakistani airspace, just to reach the combat zone. The Hornet struggled heavily with this distance, requiring massive aerial refueling support just to make the round trip. But the F-14 Tomcat, with its massive internal fuel capacity, thrived in this grueling environment. Tomcats would launch from the deck of the USS Enterprise or the USS Theodore Roosevelt, fly deep into the Hindu Kush Mountains, and loiter for hours above American Special Forces and CIA paramilitary teams. When a ground controller called for close air support, the F-14 would sweep its wings back, dive into the valleys, and deliver laser-guided bombs with devastating precision onto Taliban cave complexes. Is it not the ultimate historical irony that a 20-ton interceptor, explicitly designed to shoot down nuclear-armed Soviet bombers over the freezing Atlantic Ocean, ended its combat career acting as flying artillery for men riding horses in the deserts of Afghanistan? The final combat deployment of the F-14 Tomcat concluded in early 2006 aboard the USS Theodore Roosevelt. When the last Tomcat trapped on the flight deck, it marked the end of an era in naval aviation. The United States Navy no longer possessed a dedicated, long-range heavy interceptor. They had traded specialized dominance for multi-role versatility, The F-14 was a product of a very specific, terrifying time in human history. It was a machine built without compromise, engineered to win a World War III that thankfully never happened. It stands as a testament to the fact that in warfare, the most lethal weapon is not always the one that survives the budget cuts, but the one that adapts to the changing nature of the battlefield before its time finally runs out. What do you think was the primary reason the F-14 Tomcat was ultimately retired? Was it A, the astronomical financial cost and extreme maintenance hours required to keep the aging titanium airframes flying? Was it B, the end of the Cold War and the complete disappearance of the Soviet bomber, threat it was built to destroy? Or was it C, the political lobbying in Washington and the rise of the more efficient, budget-friendly FA-18 Super Hornet? Let me know your choice and your reasoning in the comments below.